Okay, so now let's look at basis transformation or vector transformation from one basis to another with an example. Now, this is the same question that was given in the first pop quiz, and a lot of my friends couldn't solve it. So let's solve it now. So look, first let's read the question. Given vectors v, b1 and b2, all written in the standard basis. What is the standard basis? The standard basis is e1 equal to 1 comma 0 and e2 equal to 0 comma 1. Okay, this is the standard basis. Basically your e1 and e2. Okay, I'll take e1 as a1 and I'll take e2 as a2. Okay, because I've done the derivation using a1 and a2, so I will use the same alphabets here. This is my standard basis. Now they're saying that all of these vectors are written in my standard basis. That means all of these vectors can be defined as a linear combination of my standard basis. Okay, that's what it basically says. Now they're asking what is v, this vector, in the basis defined by b1 and b2. You are given that b1 and b2 are orthogonal to each other. Now this, I think, as far as I know, or as far as I understand, this last sentence that you are given that b1 and b2 are orthogonal to each other basically means that a solution exists. Because if they're not orthogonal or if they're parallel, then a solution can't exist. They have to be perpendicular. I think that's what it means. I could be wrong, but let's just go ahead with this example. So they've written that all of them are written in the standard basis. That means b1 and b2 can be written as a linear combination of e1 and e2 or a1 and a2. So I'm going to write b1 as 1 into a1 plus 1 into a2. This will give me 1 comma 1, which is my b1, right? And I'm going to write b2 as 1 into a1 plus of minus 1 into a2. This would be written as 1 comma minus 1. Okay, this is basically my b2. It's given in the question. Now, if you look very carefully at the derivation I've done up here, this matrix of 1, 1, 1, and minus 1 is basically the coefficients of b given in the basis of a. Okay, also called as x in the derivation that I've written above. That matrix is basically this. Okay, now I have to find what is the coefficient of the vector v, that is this vector 5 comma minus 1 in the basis b. Okay, this is equal to the coefficient of the vector v in the basis a. And what is this vector 5 comma minus 1 in the basis a? It's just 5 comma minus 1. This is the formula I've written up here. Coefficient of b given a, b in the basis a, which is the matrix x, equals coefficient of v in the basis b equal to the coefficient of v in the basis a. It's the same formula that I've written. I hope you all understand how we arrived here from this practical example. Okay, so this is basically just equal to 1, 1, 1 minus 1 into the coefficient of v given in the basis b. This is what we have to find. They've asked us to find what is the vector v, which is 5 comma minus 1 in the basis defined by b. This is equal to the coefficient v in the basis a. What is v in the basis a? They've given that v is defined the standard basis. So it's just 5 comma 1. It's just 5 into a1 plus minus 1 into a2, which is just 5 comma minus 1. Okay. So now if I have to find what is v defined in the basis b, I'm just going to take x inverse and multiply it by what is v defined in the basis a, which is basically 1, 1, 1 minus 1 inverse into 5 comma minus 1. Okay, so The inverse of this is basically you switch these two, minus 1, 1, and you put a negative sign in front of these two, you get minus 1, minus 1. You divide by the reciprocal of the determinant. The determinant here is 1 into minus 1 minus of 1. So that's 1 by minus 2. Yeah, should be at 5 comma minus 1. Okay. So now when you multiply this, simple matrix multiplication, you get minus 5 plus 1 and minus 5 minus 1 divided by 1 comma 2. Sorry, minus 2. This is 1 comma minus 2 upon minus 4 and minus 6, which is basically 2 comma 3. Okay, I've just divided it. So if I convert 5 comma minus 1 from my basis in A, which is defined by 1 comma 0 and 0 comma 1, to a basis in B, which is defined by 1 comma 1 and 1 comma minus 1, the vector will basically be 2 comma 3. This is the answer to the question. Very simple question. If you understand this derivation well, this entire derivation that I've done, this question is very easy to do. It barely takes 2 minutes. So I hope you all understand how basis and basis transformation works. This is the answer. 2 comma 3 is the answer to that pop quiz question. So I'll stop here, and in the next video I'll explain SVD.